It's day 4. What now? Hi and welcome to another episode. And what I've got here is the PiHut Advent Calendar. Let it glow. We're on to day 4. I forgot what day it was then. Day 4. Let's get on and see what is inside. Obviously, getting quite used to the idea of some components being stuck in there. I mean, that is the whole point of this thing, isn't it? I'm finding these little plastic bags fiddly. Come on, there we go. Some parts. We have something that looks like a row of LEDs going by components I've seen before. And this thing, I think it's some kind of a resistor. One with many legs. I'm not too sure how they work, but I've seen them in things. And then some jumper wire type things. Right. So shall we do what we normally do and go have a look at the website? Just let me bring that up. Where it's hiding. There it is. Right, so we've got that installed, and for some reason I've managed to type 3 on Thonny. We'll delete that so there's not a mistake for later. Right, anyway, back to the important part. Let It Glow Maker Advent Calendar number 4, brilliant bar graphs. Oh, it's a bar graph, that's what that's known as. Day 4, Let It Glow, blah blah blah. It is, today you'll find a new blinky component, one of our favourites, in fact, a bar graph display. Whilst essentially it's just a set of 5 LEDs in a row, the compact size and closeness of the LEDs means you can make some really cool effects and projects with these. They're great for displaying progress, counts, or other data. We're going to reuse some of the knowledge that you've picked up over the past couple of days. I know I'm summarizing of what's been said, but that's basically that. So, 5-segment bar graph display, a network resistor. Oh, so that's what it's known as, a network resistor. And 6 male-to-male jumper wires. Okay. Today's activities. Today we're going to learn how to use a bar graph display, including wiring it up with a network resistor in your box. We'll explain what these handy little resistors are in a moment. Nice, because I'd like to know what you're supposed to do with them. We'll use the LEDs to display information from our code and also show you how to make some nice effects with these. First, let's tell you a little more about today's components. How does a bar graph display work? We already know that an LED, we already know what an LED is and how they have 2 legs, one anode, positive, and the other cathode, negative. A bar graph display works exactly the same way, but it just has more than one LED, which means more legs. Fair enough. Right, you'll notice that the legs are on the same length too, so how do you tell which leg is which? If you look closely, you'll see that one of the corners of the display has a flat edge. I understand what they mean, but corners have 2 flat edges, surely? Anyway, from what I can tell from the photo, which is could have done with a dark background behind it to make the white stand out a bit more, but anyway, it's kind of like someone's taken a slice of cake. Let's zoom in a bit and see if we can see on this thing. I know we've got a photo right there, but it's kind of bright. Zoom, 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 zoom. I know it's a very slow zoom, but there we go. At least I've got one. You can just see. Oh, let's peel this thing off. It's not peeling off, is it? One moment. Let's see if I can peel it off camera. There we go. Got a bit of it. Right, let's try to bring this back into shot again. There we go. Wow, we're looking for this corner. Sort of tell, can you maybe see against my skin colour? Right. That top right hand corner, this one, that one there, is cut off. You can't really tell from the top, but it's from the edge. You see there's not a nice sharp corner. It's sort of like someone's decided, right, I want a bit of cake, but I'm not going to tack the whole cake, I'll just cut off this corner. That's what's happened to it. But we can also go by at least by their example photo and this one, that the writing is across this side. So this is pin 1 according to them. This one here. Right, so we'll put that like that so we don't forget. But remind me in the comments. Let me zoom back out again because obviously I've done it off. Zoom out again. There we go. That's what I was meaning. Leave that there. And we've got the jumper wires. And we've got the resistor. Right. So that's what that is. We need to hook this. We need to hook up each LED leg to the GPIO pin and others to the ground via a resistor. And we're ready to code. That's good. Oh, so it's not, no, sorry, that pin 1 is it's a ground or a cathode pin. Oh, yeah, ground or cathode on that side, negative, and then all the positives must be across the bottom then. Right, okay. I'm not being funny, they're writing on it and stuff. Couldn't the makers just put like a big black dot on that side? They're writing in the middle, so just put dot on that side. Or something, I don't know. Just wondering what. Oh, I took it off camera, but yeah, there's some kind of markings on it, but I haven't got my reading glasses. Anyway, that is that there. That's what's important though. We need to make sure we've got it the right way around. So that's negative though at the top right, that pin 1. I'm being funny. Is any other kind of markings on it? I don't think so. Whatever it is, it's tiny. How does a network resistor work? When you're dealing with multiple LEDs like these, we are with the bar graph display, it can get very fiddly trying to carefully fit lots of skinny traditional resistors into the breadboard right next to each other. In this scenario, we prefer to use network resistors, also known as resistor arrays or resistor packages or resistor networks. Okay. This little black component essentially has 5 resistors inside and a single pin to hook them all up to ground, taking away lots of work for messing around with individual resistors and wires. Notice how the body of network resistors has a dot next to the letter A. That dot is common ground. Let's get our circuit wired up and see. Oh, let's try that again. Let's get our circuit wired up and we'll show you exactly where everything goes. Yes, please do, because I'm obviously having trouble today. Right. We need to find the dot to letter A. So I can see if we can do a dot to letter A on this thing. No, I can't do that one. Right. I'm going to zoom in again though, so we can have a look. As we get older, we might need glasses. There we go. So there's a letter A. And then there's a dot to it. Not being funny, but the instructions would be nice to have a photo of that as well. But yeah, there's a. Oh, stay in focus. This end, it says a dot, but it sort of looks like a diamond for a pack of cards. So that is the cathode, wasn't it? Or the ground. Oh, so it's the ground on this one. Right, so let's put that way so we know everything that side is cathode. Oh, let's zoom out. Why isn't the camera zooming in and out? It should know where I'm wanting it up. Basically, I've put the dot at that end so I know where I'm going. It seems, if you can see the writing on that side, that's where the negative is. Right. Let's construct the circuit. Oh, we seem to be. As always, make sure your Pico is disconnected from the USB. I've done that already. Please make sure yours is. So let's bring this into shot now. Maybe zoom out a little bit more. these out of the way. First, remove the LED resistor and the wires from the circuit and put them back in box 2. Okay. Getting out box 2. Alright, we need to remove the LED. We need to remove the resistors and these wires. But we appear to be leaving the ones that we put in yesterday. Right. So let's put number 2 back so we don't lose it. And put them back in. We won't use that for today's activities. Leave the 2 buttons in place for now. Your starting point should look like this. It does because of the wires that we had from yesterday. Right. Fit the bar graph and network resistor. Grab your bar graph and fit that on the breadboard, straddling the center break with the ground pins, the flat corner edge in the lower side. Okay. It should look like this. Okay. That's pin 15. It shows pin 15. It should be even further up. What? So, for them to be really annoying in the photo they've put it in pin 15. You know, so it straddles the points. But in the diagram, they've done it from pin 20. That helps. Oh dear. Supposed to be teaching newbies, and when you're teaching newbies, you have to be very careful on what you're doing. Now, which one am I going to pick? I'm going to go by the diagram, not the photo. Because I am doing. Right, and then we need, so you should have put that in, what's the letters for that? E20. I'm putting them in E20 for the, you know, the top right hand corner. So because we actually want that cut off corner in the bottom left now. So I want it like that. So you can see that there's some writing just about in this very small corner. So the writing's on this side. The chopped off cake bit is what I'm pointing at. And then we need to line that up on row H. I think it's row H. Yep. No, not H. Let's try again. Which row is that? Row I. Sorry, I'm trying to. Everything's tiny and it's not going in. Ooh. Let's try this again. I'll tell you what, take that back out again, the LEDs, because you need some chance of getting this in. So we're putting the dot to the far left. We want the pin that is on the far right in hole 20 on row I. No, is it I that we're doing it on? Sorry, yes, row I. And it's not going in. Dear me. This is definitely fiddly. At least I'm finding it fiddly. There we go. You have to use both hands and push it down. Right. But because this wasn't in the way, it was a lot easier to put in. So again, the chopped off her birthday cake is in this corner. The writing is facing the Pico. We want that in row 20 as well. So it's coming down. So there should, yeah, definitely how it is. They should actually, I know in the diagram you only see one row of dots in between the two components, but there's actually two. It's just because the way the diagram shows it, it's actually hiding that next row up. So there should be 2 rows of dots in between. Probably doesn't matter in the long run, but as long as the rows are right. But that's how that is at the moment. That's how I've done it. But the photo should definitely be matching the diagram. Fit the jumper wires. Now to wire it up, start with the ground wire, connect one end to the ground pin on the physical pin 18. Okay, do the wires match up in colours? Oh, close enough. Alright, so let's get the green wire. And we're going to take the ground. A minute. Now wire it up. Start with a ground wire. Connect one end to the ground pin at the physical pin 18, and then connect that to the other end of the dot of the network resistor. Okay, so I'm not going to use the green one then. I'm going to use the purple one because that's the dark color. Or should it? Does it really matter? I don't think it really matters. No, it's got purples there, hasn't it? It's got green, purple, orange, yellow, and blue, but there isn't a blue. We'll change blue for white. Okay, sorry for confusing matters. I'm holding the brown wire. We're going to use that as the ground. So that should be pin 25. And we're going across to pin 18. And now it's saying, now for the GPIO pins, each of the LED segments, all 5 of them, need their own GPIO pin. Okay, so we've done the ground one. Now we're going to work from left to right. We need is that going to, because of the way that we've done it, that's pin 20. A minute, that's 1, 2, 3, 4, 5. Yep. Pin 24 goes to pin 17. Little diagram would have been nice. Right, purple one, pin 23 to pin 16. So I'm working from the top board, row A, and I've used pin 24 to pin 17A on the bottom, sorry, A17 on the bottom row, and then pin A23 to pin A16 on the bottom. Going for an orange one now. Well, it looks somewhat orange, it seems to be red, but okay. So that's the top one, 22A, or A22, I keep saying it the wrong way around, sorry, A22 to 16, so stuff. And then on the next one, basically the next one along, I can just do it that way. When you've got the first one right in this particular case, it's easy enough. So, but then this last one, we've got to be careful with this last one. It has to actually go in the lower A12, not 13, A12. Basically, there has to be a gap You can't really see it here, can you? There has to be a gap, as you can see in the diagram there, between the last two, because basically there's ground in the way on the Pico, so we're moving across one. Come on, we need to get on with this now, don't we? A few tips and pointers. Again, I think these few tips and pointers should be before you start stuffing things in. Make sure it's all correct, and now it's making sure that it's plugged in and ready to start doing some programming. So here we go. For me, because I'm using a USB extender cable, that's it, it's now plugged in. Got to be careful now and not drop everything on the floor. Right, we'll start with this simple test code to confirm our circuit is wired up correctly and working expected. Test code below uses everything we learned and nothing new, so you should be able to understand what it's doing. Remember that we said the display is essentially just 5 LEDs. That's how we're coding it, setting up 5 GPIO pins and LEDs like we did in day 2. Fair enough. The script below should light up the segments one by one, then turn them all off. If it doesn't, go back checking your wiring. Sometimes it helps us to start again. Be sure. But I'm putting a caveat in there because they've not said it. When you go back to check your wiring, if there is a problem, unplug a USB first, because obviously you don't want power in and shorting something. Right, so as always, copy the code. Oh no, sorry, press stop on here to wake up the Pico, so the computer recognizes the Pico. We've already copied the code. We're going to paste it now, and then we're going to run it. And you can see it because of all the wires in the way. Right, let me turn the lights down a bit. There we go. Let's try to get some of these wires out of the way without bending everything too badly. Can you see it now? Is it all going to cover it up again? Well, if I have to hold it, I have to hold it. Right, so press play. I'll run the program. There we go. I've managed to wire it up all correctly and it went through them bit by bit. And now we make sure that it's turned off, all of them off as well. That's good. Easy segment control with lists. Did you notice how long the code was just to run the LEDs on and off? On and then off again. This is because we're now dealing with 5 different LEDs and GPIO pins control them. Lots of lines. There's a better way to manage lots of things like this, such as using a list in a for loop. So we covered for loops on day 2, which with the range function, but this time we'll use the loops with a list. Okay. In MicroPython, a list is a place to store numbers of things, such as our LEDs, that we can refer to in our code by using the name of the list. Let's jump straight into it with this example. The code below sets up the LED pins, but then adds them all to a list called segments. We then refer to this list in our loop, which will turn on each LED in our list, which is second delay after. Okay. The program keeps running through the list in the loop until it reaches the last item, and then we'll carry on with any code below. Finally, we run another for loop to turn all the LEDs off without any delay. Remember, you don't have to use the for LED. It can be for I or for X or something else. It doesn't matter either way. You can even use it for Santa if you wanted. Just to make sure that it's all the same in the code. So it's saying i.e. Santa.value and then 1 in brackets. Which is fair enough. This is what I was trying to explain yesterday. Variables are just words. I don't know, labels. And then for a box, and everything you stick inside that box is the value of that box. It's sort of how you can think about it, but when you get coding properly, it becomes a lot easier. As I said, I've done coding donkeys years ago, just haven't done it recently. And here's some example code. Okay, so we'll copy that, and as always I'll delete everything from before, paste that in, and let's run it. But let's have a quick look at the segments. So segments, we're having seg1, seg2, seg3, seg4, seg5. So segments of them. And then for LED in segments, LED for 1, and then the time is 1. So basically what it's doing is it's going to start off counting at 1. So it goes segment. So what is in place at 1? Because what we've done here is pointed out that seg1 is the true pin 13 of the Pico, and 12 and 11, 10 and 9. Okay. Not true pins, sorry, the pins in the realms of the GPIO. Sorry, not the true pins, the GPIO. And that's want them to do the pins. And then we've made segments have seg1, seg2, seg3, seg4, seg5. So basically we've initialized on what seg1 actually is, and so on and so forth. And then we've created the segments. And now in this loop, what it'll do is LED in segments. So the first part of it, because this is going to be equal to 1. So placement 1, because this is why it says LED all the time, but the very first value it's going to put in is 1 in segments. So what's in first place of the segments in the database, because now this is a database or an array. It's an array, sorry, not a database, it's an array. That's an LED. So that's 1 in segments. So the first place of the array is 1. And then we want that to equal 1. We want that to turn on, sorry, because that's what that will get fed back. And then we want it to pause or delay or sleep for 1 second. And it'll do that, and then when it's done that, it'll go back round again. And it'll keep going back round until there's no more in the array. So the next time around, it'll be 2 segments. So at 2 is seg2. So it'll send the information off to pin 12 that it should be on. And so on and so on and so on. I hope I've made that somewhat legible what's supposed to be happening. And then at the end here, it's doing it all but without the sleep. And this time though, it's setting them all to off. So I get the impression it should go like it did when we first did it. It went dit, 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 or 5, and then suddenly all 5 will turn off. I believe that's what's going to happen. Let's press play and find out. There we go, I guessed right. As always, I say that you should type these out yourself. You shouldn't just cut and paste and quickly do it like me, but I don't want to bore you too much with me babbling on. I just want to hopefully give some help on understanding what's going on. Anyway, time to have a bit of blinky fun. We're going to create an LED scanner that runs from one side to the other. A famous example of this is the car Knight Rider from the classic 80s TV show, where the vehicle had a scanning red light at the front. I remember that. It went vroom, 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 sort of thing, didn't it? There are a few ways we can do this. We've opted for a method in which we think this is the clearest to read and understand. The initial code is the same, setting up LED pins and putting them in a list. We then start a while true loop. Basically, it runs forever while it's true. Inside this while loop, we'll start a for loop, initially to run through each LED and turn them on and off again at 1 line at a time with a time delay, similar to what we did before. Once the first loop runs out, the items are listed, ends and moves on to the next one. Here we can run a reversed version of the loop, which means that it will go basically from the other end backwards. So it will go. Do you like my sound effects, by the way? Anyway, right, to do this, we just use the word reversed and place that list name in the brackets after it like this. So for LED in reversed segments. Okay, so that makes sense, doesn't it? So let's stick the code into Thonny and let's have a quick look again. So like before, as they say, you know, we've got these different segments and we're setting them up to the different pins. The segments have been initialized into being seg 1, 2, 3, 4, and 5 while true. So unless it's for any reason we pass this to be false in our code, it'll just keep doing it. So this will be one where we'll have to actually press stop. For the LED, we've seen this before. It's going round and round and round. You know, 1, 2, 3, 4, 5, 6. Well, sorry, 1, 2, 3, 4, 5. Turning them on because we know that 1 means on. Time sleep, we're only doing it for 0.08 of a second. That's not a long period of time at all. And then it's turning it off because we know that's 0. And then, as it said in the bit of information just now, it's doing it in reverse. So instead of going, because when it's finished here, LED will actually equal to 5, right? As a pointer in the array, it will equal to 5. So yeah, but here it will start here at 5, but because we've said reversed before segments, we're telling it actually we want to do -1 in counting now. So I want to go 5, 4, 3, 2, 1. Oh, and then it'll, but then the way that Python works is that it will go back to the while true because we haven't told it false for whatever reason. So all it'll do is just go back to the top and go start again, going 1, 2, 3, 4, 5, and then 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Which means we are going to press stop when we get bored watching it go backwards and forwards. I think that might take a little while to get bored of it doing it, but let's press play. And I'll move the wires out of the way so you can see. So there we go. We've got, oh, quite a fast little Knight Rider going on. But that's cool. That's very cool. I like that. So we press stop. And you see, this is the thing now. You see, it's hit stop. And it's left the lights on. It's left the light on because there's nothing else to do there. So what we could do, just to make sure that the code for next time around is working, we're going to type in, oh, how are we going to do this? This is interesting. We should just be able to, because the LED value, you know what, no, I'm going to leave it. I'm going to leave it because we need to do what they're telling us to do. So random LEDs. Another fun little trick we can do is randomize the module. This module is random number generator, or RNG, and that will randomly select which LED to light. To use the random module, we first need to include it as an import as start of our script. Then after the usual LED pin setup and list of creations, we jump straight into the while true loop to run over our code over and over. Inside our while loop, we first create a variable r using r equals random rand int 0, 4 in brackets. This line is saying give me a random number, an integer, that means a whole number, between 0 and 4. We do this as we have 5 LEDs and we want to randomly choose one of them to light up. You might be asking yourself, why isn't it between 1 and 5? MicroPython always starts at 0 for lists and similar things. It's called index, and indexing in MicroPython always starts at 0. Aha. So when I was talking about it was doing 1, 2, 3, 4, 5, it wasn't. It was doing 0, 1, 2, 3, 4. Ah, so there we go. We've learnt something with that. I'm probably thinking of some very old programming languages where you do actually just start at 1. But right, the point is we start at counting at 0. That makes sense. It does make sense. Right, the last part of our program is telling the code to light the matching LED. We're using a segment r.value1, which is lighting the LED in our list segments with a number or index r that is randomly chosen. Okay, that makes sense. Are you keeping up so far? If you are, tell me, because it's a lot of information. The same R is used to turn off the same LED after delay. When the code loops back to the start, a new random number will be generated. Right, so as always, we'll delete the code from last time. Oh, let's try to find this code. There we go. Stick it in, paste. I've already gone through talking about it, so just press play. Have we really talked about it? Yeah, we have really. We've, as before, set it all up, put it in the segments, but now we know that's actually value, well, of where its index is, it starts at 0. So 0, 1, 2, 3, 4 is the arm standing for random. Between 0 and 4 segments, which light it is, and the sleep time. The segments are, and turn them off again. So basically, the value's already there, whatever the randomized one is. So if it picks 3, you remember where that will be on here? That'll actually be segment 4. So the 4th one will light up, and then it'll delay it for 0.1 of a second, and then it'll turn it off again. And then it'll go back to the top, randomize a number, stick it in there. If it picked 1, where would it go? It'll be segment number 2, because that's 0, 1, 2, 3, 4. Leave it on for a little while, turn it off, rinse and repeat, rinse and repeat. Okay, so let's play. There we go. So we've got a little disco light going on now, haven't we? Oh, I actually did it in, looked like it was doing it in order then. But yeah, so a little disco light. Wouldn't it be cool if it was like different coloured LEDs? So we'll press stop again. Activity number 5. Oh, this one includes buttons. Let's use our bar graph display along with our buttons to use it as a little counter, allowing us to track something up to 5. To do this, we need to return the if statements from day 3 and learn a little more about them. We need our code to count each time we press each button, keep track of the changing number, and light the right number of LEDs. No, not the right number of LEDs, the correct number of LEDs. Right is a direction. We also need to tell our code what to do is get the minimum or maximum count. And I know I'm being picky about that right, but when you're reading things in code and someone says right and what they actually mean is correct, it can put you off if you're also dealing with left and right. So use the word correct when you're meaning correct, not right. Anyway, a nested if statement. Oh, we're getting to nested if statements already, dear me. And it's literally what it says there is just an if statement inside an if statement. So like nesting dolls, like the Russian nesting dolls, you know, the inside. That's what it is. It's called nesting. They're really handy and as allow as a condition to check after the first has been already been met. Right. The rules around indication continues here, so you need to make sure you continue to indent for the nested if statement. We'll show you an example in a moment to make that clear. Right, so move on to else statements. So an else statement says if none of the statement above have any of these conditions meant, do this instead. So does, for example, there's an example, but are oranges red? If they are, do this. If not, do this instead. and that's basically what you're sort of looking for if none of the conditions are met. Because the thing is, you see, oranges are orange, or at least most of the time they are. So that's how it sort of works in the realms of you're looking for something that, whatever it is, sometimes you want to look for the negative point first, and sometimes you want to look for the negative. Sorry, look for the positive idea first, and sometimes you want to look for the negative idea first. It depends on what you're trying to do. If it's only two of them, it doesn't really matter, but when you have lots of them, it can start to matter what you're looking for. Right, so anyway, let's get on with doing this. So, it's your example if you're using one button. Here's a short example you can try using just one button, where we always print no button pressed if the green button isn't being pressed. The commentary shows where the else statement is being used. Okay, so as always, we get rid of the last bit of code. Come down here, we'll copy the code, stick that in. So what have we got? Green button, I'm checking for a green button. While true, so basically just keep doing it. The green button is being pressed. So, wait for a delay, and if the green button is being pressed, it'll keep pointing to the little shell area that the green button is being pressed. If no buttons are being pressed, it will say no buttons are being pressed. Okay, that's simple enough. This has nothing to do with the LEDs at the moment. So no button pressed. I'll press my finger past all these wires. Pressing the green button is being pressed. I'm letting go. No button press. Fine, that works. And we'll press the stop button because we don't need to keep doing that. Right, so the code that we are chasing is we use the LED in the list again to create variable count set to the, remember it was -1 and +1 that we did last time. Why do we use -1? Because if you remember from earlier, the MicroPython always starts at 0 for list index or the indexes. So our first LED is technically LED 0. If we started the counter at 0, the first LED would be lit immediately. You'll see why in a moment. Okay. Our code then starts with a while loop and then two if statements checking if either of the buttons are being pressed. When one of the buttons is pressed, it jumps into the nested if, so it knows to do something. Okay, right. Taking the first one, the red button as an example, the nested if asks, is the count index 4? Are all LEDs lit? If it is, we tell our code to pass, which is just a way of telling the microcode to do nothing. Okay, so basically, since we've only got 5 LEDs and we start counting at 0, the last counter point, or the last index point, is 4. And if we were trying to add 1 to 4, it would give us 5, but there is no 5, because that would be the index marker of 6. Sorry, that would mean LED 6, which would be the marker of 5. The index value of 5. Oh, try saying that one again. If we're already at 4 on the index, we can't have an index 5 because there's an LED for it. So we'll just ignore the button being pressed. I should have said it that way first. Right. Okay, so we carry on moving down. And if it's for the else statement, we'll run. Our else statement adds 1 to the count, then the LEDs that matches the count number using segment counts value 1. A count variable is injected into the code using count. Take a look at the other section, the green button. It's doing the opposite, working to turn off the LEDs and reduce the count. Copy the code below. Okay. I know it's starting to sound quite confusing, but it's a little bit of step-in logic, but we'll see what happens. So we paste it. So we've set up, the stuff for the fact that we can do time. the pins and the time and doing the random button. We've got the red button, pin 2, green button's on pin 3. We want to be able to control the values of them, check to see if they're being pressed or not. Different segments so that they're actually being sent there, those pins, and then the segments of actually those parts. We want count to start off with -1 because we want the very first value to be 0, because that's what we want. Because we want the first one, remember there's a marker of 0, so we have to actually be down 1 below that, because otherwise as we started at 0, if that was 0, that would be started as lit automatically and want it to be turned off. I realise there's an LED still turned on at the moment, but that's because they don't put in any initialization into the code to make sure everything's turned off first anyway. But anyway, we need that to be there. So if we pressed the green button, sorry, which way around is it doing it? Yeah, so the red button to add 1, that'll take that to 0 and that'll light up. It's basically how it's going to work. So we do have to be a volume below, a value below. And this turns them all off. So we are actually initializing it. It's the first time they've done this. This is what they should have had in the code always, is that it turned off. No matter what's happened before, it's turned off. So when we get this running, that LED will turn off now. The sleep timer is going to be a very short period of time. Checking to see if the red button's been pressed. If the red button's been pressed, and if count is equal to 4, do nothing. If the red button is pressed and the count doesn't equal to 4, we're hitting this else. So that means then what we want to do is add 1 to the count. So now if that was 3, because it has to not be 4, if it was 3, count plus 1, so now it would be 4. That segment number 4, which is the 5th LED, will be turned on. Wait for 0.2 of a second. Now check to see if the button's being pressed. If it's not being pressed, go back. If it has been pressed, is the count equal to -1? If not, basically take it, turn it off, count down 1, wait for a bit and then put the count, turn that LED that's last been left on, sleep for a little bit, and then knock the counter down by 1 and go back to the start and keep doing it to this bit. It won't keep going back up here again, it'll just go to here again. So let's press run. As I said, the LED is instantly turned off. Let's press the red button. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Haha. Obviously it doesn't work like that, does it? It's 1, 2, 3, 4, 5, 4, 3, 2, 1. And then again to turn it off. Because we're at -1 right now. So the way that it's counting in there, though, I know we were counting a different way, but how it's counting at the moment is -1, 0, 1, 2, 3, 4. Press again. Nothing's happening. The counter isn't actually getting added to, because there's no point. We've made a trap for it, basically. There's no point because we've got no more LEDs. And then three, 2, a minute. Where are we? -1, 0, 1, 2, 3, 4. Now we've come down to being 3, 2, 1, 0, -1. And that's that code. Right. A little bit more long-winded today than it was yesterday, but there's a lot more to it. Day 4 complete. There we go. As I said, there was a lot more to it that time. I've learnt a lot myself today, actually, because, as I said, it's been very long time since I've done any Python. Quite frankly, I think I've forgotten how to program in Python. But the little bits about programming I do know, it's coming back to me a little bit. No expert, not saying I am. But I hope you've learned something out there. Please put in the comments if you have. If I can help you anything, check the Discord links down below. Check out the Patreon links. Don't forget to hit that like, subscribe and notification bell so you know to come back tomorrow. But as always, happy gaming.